That gives me the opportunity to move on to our final story for this evening, which is our guest, Dr. David Helfand. And David, why don't you come up and join us, and we'll tell you more about him as he joins us. So you can get grilled from both sides.
I see.
How that is. So, as I mentioned, Dr. Helfand is still an astronomer at Columbia University, chair of the department, and then left for 7 years to go to Quest University in Canada. And I know not a lot of people in here know what Quest is, and so he will tell us about it. But I think before we turn off the slides and just turn to conversation, we have to at least show the picture of David as I knew him. Where is that picture? There he is. Long ago, I'm sure you've seen that. So well known for his superb education skills. And so with that, I think I will just start asking you why in the world, and I think we should, can we turn off the
No, we can leave it there.
You can leave it there? Yeah. Okay, you like looking at
I was only once charged to 50,000 volts, and that's it.
That was it. My question for you is, why did you leave? I mean, New York City, department chair, Columbia University, that's a pretty great situation. And you chose to leave and go out to British Columbia and do something quite unusual. So let's start with why you chose to leave.
Well, universities today are excellent preparation for a job in the 19th century. The only problem is we don't live in the 19th century. And I got to Columbia in the 70s and thought, this is great. Columbia is the only major university that didn't abandon the notion of general education, that every student, irrespective of what they're going to major in, should actually learn some things in common. They should read some books, they should look at some art, they should listen to some music, they should discuss in small seminars important ideas. But I was simultaneously appalled that this core curriculum, which had been in place for 80 years, consisted of 7 humanities courses, 0 science courses, 0 math courses, and 0 social science courses. But being young and naive, I thought, well, I can change that. We have this requirement. People take courses in their first 2 years. I'll just add math and science courses. And 27 years later, I succeeded in adding 1 semester to Columbia's curriculum. So now as it approaches its 100th anniversary, it has 8 courses, 7 humanities courses that haven't changed since 1937, and my science course. And the year I accomplished that, which was 10 years ago, I got a call from David Strangway, who in fact has relevance here because he was in charge of the Moon Rocks program during the Apollo era. He's a geophysicist, and subsequently had been president of the University of Toronto and the University of British Columbia. And he called me up and he said, David, I'd heard what you've done at Columbia. We're starting a brand new university from scratch, and I want you to come out and talk about integrating science into a liberal arts curriculum. And so I did the obvious calculation that in 27 more years I'll be dead. So I'll never add another course to Columbia's curriculum. And so I agreed to go for 1 day, and that was a decade ago.
1 day. And what happened? You went out, you saw the place, where is it?
Well, it's between Whistler, where the Olympics were, and Vancouver. So it's on the end of the southernmost fjord in North America in this beautiful mountainscape. And, well, we started with a blank piece of paper and said, how would one design a university for today, not for the 19th century? And how would one design a university for today's students, not versions of ourselves 50 years ago, or in your case, only 20 years ago.
Thank
or,
you.
Yeah.
So when, what are the differences? Why is the standard curriculum in a university not sufficient for today's young people?
Everything is different. So, the standard thing is someone who looks like me stands there, right? And you all sit there really quietly, and I lecture at you, right? I pour little bits of knowledge out of my beaker full of knowledge into your little empty beakers. And then I ask you to regurgitate it on command, and you all do that, and you get your A's, and you go away, and you're happy, right? So...
No, we drink all night, we don't do the
well, that's
homework.
true. That's also true, but anyway. So I don't think this fits this age, because this age, all the information in my beaker and a million other people's beaker is 2 swipes away on your phone. So the notion of education, of transferring information from one person to another, makes absolutely no sense anymore. What one needs is to be equipped with a way to filter information from the tsunami of misinformation that threatens to overwhelm us, to validate that information for yourself, and then to have a set of intellectual tools, not defined by 19th century disciplines, that allow you to combine that valid information in new and creative ways to produce something of value to yourself or to society. So it means we have to throw out everything we've done. I came out with my boxes of lecture notes, and they are still in their boxes 10 years later. One has to completely reconceptualize what the point of education is, and then you have to reconceptualize how to do it.
So tell us, well, that's two parts. So let's start with the reconceptualize the point. What is the point?
Well,
of
it's not really a new idea, right? Jun, the Confucian philosopher, 2,300 years ago, summed it up very succinctly, as Confucian philosophers are wont to do. He said, "Tell me and I'll forget, show me and I may remember, involve me and I will understand." And so, I could take any example. Last block, oh yes, well there's lots of details here, but last month we had a course called the hydrological cycle. So that's a geology course or a atmospheric science course. And these students come in and they buy a $150 textbook and they've got all these bold-faced words, and they memorize the words. And then someone who looks like me writes stuff on the board and they copy it down, and that's the way it goes. But at Quest it goes a little differently. So the hydrological cycle for us, because we're between the ocean, this 9,000-foot volcano behind us, starts up at the volcano at a frozen lake with a glacier. And so the first day of class, they come in with their winter camping gear and their snowshoes, and they go hike up to where the hydrological cycle starts for us in the coast mountains. They set up a little weather stations. They try to predict when this meltwater from the lake is going to start going, because it's May, and that's when it about starts to go. And they have to make quantitative predictions of when the meltwater is going to start down the river. And then they come back to warm up for a couple days, and their prediction, they go to test it by getting in a raft and rafting down the river, following the meltwater pulse as it goes and doing chemical and geological measurements along the way. And then, of course, as the meltwater pulse actually goes out the Squamish River into Howe Sound, which is a fjord, a salty fjord, they can get in sea kayaks and use instruments to measure the salinity change as the fresh water moves out for the year. They actually are involved in understanding what the hydrological cycle is. They're not reading about it in a book.
Now you mentioned, and I think it's worth saying, and so I'll go back to the how. There are some unique things about the way in which the courses are structured this semester. The faculty are structured, even the geographical layout of the campus. What are some of the differences about the way, if you have a clean slate and you can start from scratch, what were some of the decisions that were made about how to make this a different environment?
So the first thing was the structure of the institution, both physically and organizationally. The structure of most universities today is built on the 19th century German model. And I'm not sure what they were thinking in the 19th century in Germany, but it probably went something like this. Well, over there we've got some experts in some particular field, and they all just talk to each other. And then there's some experts in some other field up there, and there's some experts down here in some third field. Let's bring them all together on one field. We'll call it a campus, right? That's a field. And we'll put them next to each other, and we'll see what happens. And so we've learned that now. What they do is they build silos, they build towers, and the most energetic ones build the tallest ones so they can throw rocks down on the other guys at night and stage raiding parties to steal their resources. I've been an Ivy League department chair for 18 years. I know how to play this game. It's an enormous waste of time. And they all build their own buildings. Now, the big problem with this is that they all have PhDs. And as you know, the process of getting a PhD is the process of learning more and more about less and less until you know everything about nothing. And then you put the people who know everything about the same nothing in a building who never talks to anybody else. So the first organizational principle was no faculties, no departments, one faculty in a circular building with no edges, and you assign the offices to faculty by lottery. And so a mathematician sits next to a musician, sits next to an economist, sits next to a physicist, sits next to a poet. And they actually remember why they wanted to be academics in the first place, because they like to learn new things. It's just they got outside their tower so they can learn something other than what they do. And you end up with our enumerate music professor and our tone-deaf mathematician professor teaching a course on the mathematics of music and modeling learning for the students because they are actually learning for themselves. The second thing we do is we have no rooms that look like this. Every room is a seminar room with a big oval table with no more than 21 chairs around it. It's a wonderful CBC documentary you can Google called 21 Chairs Around a Table. And it's about how we do our educational model. One faculty member, sometimes two faculty members, like the musician and the mathematician, and 20 or 18 students sitting around the table. Average class size is 16. The second thing is that we assault the neurophysical nonsense of multitasking. Now I know, especially here in Southern California, everybody's really good at multitasking. I've been driving on the 10 coming up here.
Nicely
Everybody
done
was
with
at least
the 10.
doing that, and sometimes they were doing this as well, right? And those people, fortunately, will eventually be removed from the gene pool. They may take a few people with them, which is unfortunate. But the prefrontal cortex does not multitask. It can switch rapidly, but as what's his name, Clifford Nast, who sadly died recently at Stanford, showed, when people multitask, two things happen. The estimate of their performance by themselves goes up, and their actual performance goes down. And this is a real disaster when that happens, right? So normally in university you take 4 or 5, or if you're at Columbia, because you're all type A+ personalities, they take 7 courses simultaneously. And you go to class 75 minutes twice a week, and if you're lucky you spend a couple other hours doing something, especially before a test, and that's that. So we decided to eliminate this. So our students take 4 courses in a term, but they take them in series rather than in parallel. So for the month of September, if you're doing the hydrological cycle, that's all you do. That completely frees you from any schedule conflicts. So field trips are not a problem. Our volcanology class starts on the volcano also. They collect samples for a couple days, they come down to the lab, they do all these experiments on them, and then Sunday they fly to the National Observatory in Hawaii to work with the volcano scientists at the Volcano National Observatory understanding volcanoes. Because they have no chemistry lab that afternoon, and they have no English paper due the next day, because they're just doing one thing. Secondly, this allows us to actually get to depth. Students go to class 3 hours a day, 5 days a week, and we expect a minimum of 5 hours a day outside of class. So that's 8 hours a day, it's a full-time job. And we get 5 to 7 hours a day outside of class. And the depth you can reach and the level of engagement you can produce this way is absolutely phenomenal. Now, I was very skeptical, right? I'm a typical academic. I thought, I see how this would work in an English class. Because you could take a Shakespeare history play, and you could then read the history or the mythology or whatever that the play was based on, and then you could put on the play. I mean, you could really get into a Shakespeare play, but it'll never work in physics. Because, physics is ideas, and they have to build on each other, and you have to assimilate them, and it takes forever. And so it's very amusing now when I go back to Columbia and tell them how incomparable the block system, as this is called, is, and the English professors always go, yeah, I see how that would work in science. It would never work in English, of course. Everybody always knows it won't work in their discipline except the people who have done it and won't ever go back to teaching any other way. And I can give you dozens of examples, but my favorite one is this. We have a math professor, and he likes teaching spherical trigonometry, which is an astronomical thing to do, although I've checked. No university have I found in North America that teaches a course in spherical trigonometry today. Your GPS wouldn't work without spherical trigonometry, but no one teaches it anymore. But Glenn loves this subject, and he was writing a book for Princeton University Press on the development of this, because in the 19th century, this is a big deal. Right? You could navigate accurately for the first time because you were doing geometry on the surface of a sphere, not in a plane. Right? I mean, what's the sum of the angles in a triangle? 180. What's the sum of the angles in a triangle drawn on the surface of a sphere?
270.
More than one.
Up to 270.
I got more than 180, up to 270, no one gets a prize. Well, no, more than 180 is right, that's true. I mean, imagine two lines at the North Pole, meet at the North Pole, right? And they come down and they meet at the equator. So there's 90 plus 90, so there's 180. Yeah. And then there's this angle, which could be anything you want it to, right? So geometry is different on the surface of a sphere. Anyway, Glenn's teaching this class. He's got his galley proofs into Princeton University Press. He goes to class in December. It's the 4th month these people are in school. Everyone has to take math. None of these people are going to be math majors because we don't have majors, because we don't have departments. But they're taking this math class because Glenn is cool, and it really is because they get these cool lucite spheres they get to carry around, draw triangles on the surface. So it's a cool class. The 9th day of class, he puts this theorem up, published first in 1807. About 9 hours later, which is how long that class usually stayed in class, the students come to find Glenn. They said, this proof is wrong. And Glenn said, no, it's not wrong. I mean, it was published 200 years ago. The proof was wrong. The students discovered an error that had escaped mathematicians for 200 years. He had to withdraw his galley proofs from Princeton University Press, change spherical trigonometry, acknowledge the class in the front of the book. First-year students, no math majors, because they could focus on one thing, get engaged and involved, and, most importantly, work collaboratively. Collaboration in universities, Ken Robinson says this best. He said, when 3 people get together and they work really hard and they come up with a really creative solution to a difficult problem, you know what we call it in university? Cheating. Right. In life, we call it collaboration. You know, it's highly rewarded in most industries, but in university, we punish it. So we don't. We encourage people to collaborate. In fact, we require people to collaborate. And every day, they're collaborating with someone else in a pair or a triplet or a quad, and they have to do a presentation or a research project or a problem set or write a paper even, or do a big research project as the whole class over the course of the whole month and write up a research report that then gets published. And that kind of collaboration is free, doesn't cost us anything. And it forces students to learn how to work with people from very different backgrounds, different countries. We have 43 countries represented in our 700 student campus. And they learn to work together. And, you know, their 5 hours or 6 hours or 7 hours of work a night is not sitting in front of their laptop in their room with the door closed. It's collaborating with people out in the woods, gathering samples, or in the lab doing work, or in the library, in the noisy part of the library, talking to each other and arguing with each other. And it makes all the difference. So when surveys are done of CEOs or HR people as to what people want out of university graduates and they're not getting, they always say the same thing. They never say they want people who can write code faster or they know Excel better or something like that. They always say they need to be able to communicate effectively and orally and in writing. They need to be able to collaborate with people across the organization to solve problems, and they need to be resilient and see failure as an opportunity to learn rather than as something to be avoided. One of our faculty members makes the students keep a failure log, and on Friday they have to turn it in, and if they haven't failed enough times that week, she takes points off their final grade.
So you said there are no majors. How am I supposed to know what I'm to do with my life and get a job?
Good question. What is this, get a job? You don't even have a job now at work. We've known each other a long time. So, as I said, you need intellectual tools from a wide variety of disciplines. So the entire first 2 years is 16 courses, which everyone takes. Life science courses, physical science courses, math courses, social science courses, humanities courses, arts courses, and language. Everyone does all 16 courses, plus some very interdisciplinary courses, like the first one they take, the title of which is What is Knowledge?, which we do from the point of view of an anthropologist, a philosopher, a mathematician, a scientist, and an author.
Sounds like the start of a joke.
No. It's really an amazing course. Anyway, after these 16 courses, well, you say, well, they don't know how to do anything. Well, they do know how to do everything, but they don't have a set of content, right? The mathematician doesn't care if they know spherical trigonometry. He wants them to know how a mathematician looks at the world, asks questions about the world, and goes about trying to answer them, which is different than the way an economist does that, or a musician does that, or a poet does that. But they're all valuable. In the last month of the second year, they have a block, a month, guided with a faculty member and 15 of their colleagues. And each student comes up with his or her individualized question. Has to be in the form of a question, because questions are better than answers. And so the question involves picking a faculty member who'll be your mentor for the next 2.5 years. It means selecting half a dozen books that you'll read with that faculty member to understand the foundations of the field. It means selecting a set of courses that will deepen your understanding of things relevant to that, but not from one department, because we don't have departments. And it means designing an experiential learning opportunity off campus, out in the real world, in a research laboratory, in a government office, in a law firm, in an NGO in Africa, in a local community organization, whatever it is, that's going to give you practice at what it's like to pursue that question. And then all this culminates in the final year in producing a major project, which is often something that looks like a master's thesis, but can be the full production of an original play or a graphic novel or a documentary film or an art exhibit that addresses but doesn't necessarily answer your question. So each person in the first 2 years gets equipped with the tools, and then we set them free so they can follow their interests, their passions, and test out what they might want to do with their lives beyond this. And some of them find, gee, I never want to do this again. And some of them decide, this is what I want to do for the rest of my life.
Now, 8 years ago, Quest University didn't exist.
Right.
And today it is the top-rated university in Canada.
Right. So we started in 2007 in the fall, so 8 years ago, it didn't quite exist for 2 more months, with 73 students and 7 faculty members, plus me as a sort of interloping faculty member. And today we have 700 students from 43 countries and 50 faculty members. And for the last 5 years in a row, as a matter of fact, in all 5 areas of undergraduate academic excellence, we were number 1 in Canada, and in 2010, which is last year we have data for from the US, we were number 1 in North America.
So, yeah, exactly. I think that's worth it. So, is this catching on? Is anyone going to follow this model, or are those just those weird Canadians doing weird things out in the mountains?
Well, it's not mostly Canadians, because they really don't get this at all. The notion of a broad education is not a Canadian ideal. But yeah, as a matter of fact, there's a university in Ontario, public university, which last September, after visiting us for 3 years in a row, completely switched to the block system. There are several departments in universities that have switched for their majors, because their majors only take their courses, right? But they can do that then, and they like it. Next month I go to the UK, where the first new university in the UK in 35 years is being created. And their document says they're inspired by Quest University Canada, and we're supposed to do that. The Aga Khan Development Network is developing 4 universities in the Central Asian republics, 3 there and 1 in Arusha, Tanzania. And they're so enamored of our model, they visited 5 times already, that when they open in Arusha in 2019, they're going to take 50 of our students and 10 of our faculty and fly them there to do what we call Questifying the place. Make sure it comes out just like Quest.
And how about for you personally? You are going to be leaving Quest now.
I am going to be leaving Quest now, because in leaving Columbia, I left a 260-year-old, completely sclerotically stultified university in which change is virtually impossible. But I left.
I guess we won't post this to the internet.
No. They're actually used to it. It's not that the institution is bad. People do wonderful. I did wonderful research. People do wonderful research at Columbia, and graduate training is excellent at Columbia. We have a great medical school. They cure sick people at Columbia. They do urban planning at Columbia. They do everything at Columbia that actually think about teaching. I was in a meeting today at Claremont, at Pomona College, and they were saying, when you become a faculty member, you go for like 30, 40 years without ever thinking about teaching. In fact, it's punished. At Columbia, we have these 5 ranks of faculty. We have assistant professors, associate professors, full professors. Then, for very important people, we have chaired professors. And then out of the 5,000 faculty, 8 can be named university professor. And you know what the distinguishing characteristic of a university professor is? They never teach again. That's right. Exemplifies the values completely.
Wow.
Well, it's in the language, right?
Yeah.
You'd ask any university professor, say, I have a teaching load of this and a research opportunity to do this. They never have a teaching opportunity or a research load. They only have a teaching load and a research opportunity, and they're rational. So they minimize their loads and maximize their opportunities.
So what will you do when you get back to Columbia?
Well, I was going to say, I left also my really nice apartment in Manhattan, and I left my season tickets to the Metropolitan Opera, and I left, what was the other thing? Oh, my wife. Yeah, I left my wife. And so, I didn't leave her. She just stayed there. She was not dumb enough to move to Squamish, BC. So I thought maybe it was time to go back and do that.
And for your intellectual work, you have a book coming out this fall?
I do. I have a book coming out. I probably won't be till December, but it's finished. And it's called A Survival Guide to the Misinformation Age. Because I don't think we live in the information age. I think we live in the misinformation age. And this is a little bit of a diatribe against the media and politicians and general innumeracy in the public. My editor said, David, it's a little snarky. And I said, that's the point. It's supposed to be snarky. When the chair of the Senate Committee on the Environment calls climate change the greatest hoax ever perpetrated on the American people.
And throws a snowball.
It's what can you say? So it's a little snarky. But it also provides practical tips to how to make decisions on your finances and your health, and even how to vote for these idiots.
I don't know whether to jump straight to tell us a couple practical tips, or maybe we should say a little bit more about what are the choices we face as citizens when we are inundated with all this information. How do we cope?
It's difficult.
You must have some answers. You've written a book on it.
I have written a book on it, but I discovered in the course of writing this book a wonderful paper, which if you really want to get depressed, you should read. It's by Dan Kahan at Yale. He's actually in the law school at Yale, but his research is on communication about issues like climate change and other educational issues like evolution and things like that. And his conclusion is chilling. he did this test of 800 people or 16, I don't know, some huge number of people. And he tested their general cognitive ability and their science knowledge. And so he's got a spectrum, like, you'd say, to be crude, the dumb people and the smart people, right? The people who really have a lot of science knowledge and good cognitive reasoning abilities, and the people who don't. And then he asked them about the risk assessment of climate change. And he grouped them into really red people and really blue people. Right? And it turns out the dumb people sort of agree with each other. There's some risk to climate change. But as you go out, the really red people go to zero risk for climate change, the smarter they are. And the real blue people go to a disastrous risk of climate change. The conclusion is unambiguous in this paper that people use their cognitive reasoning ability to reify their group identity rather than to make rational decisions about the world. And as long as that's true, and as long as our educational system allows that, and our political system allows that, as Dan concludes in this article, we're screwed.
Well, on that note, no, I mean, clearly you're writing the book because you think there's an audience and a need, and perhaps it will have some impact. I mean, are there any rays of hope in what you have to tell us about this?
Well, I think I look at the world as a rational person. My wife sometimes disagrees with that, but yeah, I guess I've devoted 40 years of my life to education because I have to think that's the key. And so the idea is to shake people out of their complacency and to have them realize that there's lots of stuff we don't know. Right? So it's not accumulating facts, but it's accumulating habits of mind, ways of thinking that allow you yourself, to assess the validity or the likelihood of information you receive. And there's some basic probability and statistics. There's how to read a graph. There's back of the envelope calculations. There's all these little simple tricks, and I tell you how to do them, and you can practice them even in the back of the book if you like, so you can be empowered to make the decisions and not rely on authority, which is likely to be propagating disinformation, not even misinformation. And if we can get that message out to enough people, and if people take it seriously as part of the political process, and even more importantly as part of the educational system, then yeah, I have to think there's hope. But I give these talks on climate change, and I've worked hundreds of hours on this talk. It is the most careful talk on climate change that has no emotional content. It's just, here's what we know, and here's what we don't know. But when I'm giving a talk, as you can probably tell, I get sort of enthusiastic, and so I look like I'm happy. And I get to the end of this talk, which is pretty depressing.
I look like I'm happy.
And people say, the first question always is, how can you be so cheerful when this is so depressing? And my answer is really simple. I'm old,
We actually faced something here in the first couple of years of All Space Considered. I didn't want to talk about climate because it was so inflamed, and I'm a civil servant, and I have a responsibility to sort of stay away from political hot buttons and so forth. But I couldn't stand it. After about 2 years, I just couldn't stand it anymore. And so they did just that. A framework for discussing and thinking about, exactly. How do we break it down into a series of dispassionate questions, and then it finally came to the point where, again, I couldn't talk about it anymore.
Well, we got to the point where we're just screwed.
So we did for a couple of years tackle it in this program, but we haven't talked about it in a long time because. Are there any questions for Professor Helfand?